Uh, Good evening, everyone. So my name is Srikanth, and today I will be the course instructor. Hello.
Evening, sir.
Yes,
Yeah.
sir.
Good evening. Am I audible?
Good evening.
Can anyone confirm that whether am I audible clearly or no?
Yes, sir. Yes, sir. You are clearly audible.
Yes, sir, you're clearly audible.
Okay. Okay. Thanks. So today we are going to solve few problems which are replicas of graded assignment week 4. Shall we?
Yes, sir.
Yes.
Yes, sir.
For that, let me share my screen. Yeah. Is my screen visible?
Yes, sir.
Yeah. Okay. So what you have to do is, apart from joining this Zoom, you should also join from joinpd.com. So open a new tab if you are using a laptop. If you are using a mobile phone, take another device and type this joinpd.com. And whatever the code is visible on the screen, uh, please type that code VSSHKU so that we can have an interaction through this app, through this site. So once you solve the problem, you can directly enter your answer into this site. Okay. So others also try to join this. Yeah, today, as I already said, today we are in week 4. We are going to solve few problems which are replicas or similar kind of graded questions. So with this session or after this session, you will be able to solve 4 or 5 questions from the graded assignment week 4. Okay, we shall start then. Any prior questions before we start? Okay. Silence, I will take it as no. Fine. Okay. So let me just go through few slides, initial slides. So this is how the plan for this session. We are going to do this session in two sites. One is through WebEx, where this we are going to whatever I speak you can hear, and the other site is Peer Deck, which is joinpd.com. If you go into that site, you can answer the problems which I am going to show you now. And yeah, this is the important thing, as this is an solve with us session, so you should be having notebook and pen ready with you for solving the problems. And I will be giving you some 5 to 10 minutes depending upon the difficulty level of the question. So once the question appears, you have to solve it. Once you are done solving, you have to enter your answer on joinpd.com, not on the WebEx chat box. So you should answer in joinpd.com, and then we will have a discussion on the solution, and we will move to the next question. This is how it is. Can someone confirm? Am I audible? This silence.
Yes, sir.
Yes, sir.
Audible.
You are audible.
Sir,
Okay,
you are
okay, okay. So it was bit strange for me that students are this silent. Okay. Okay. Anyway, this is how the session is, and these are some example screenshots. By now, you should know this is fourth week we are in. So how this joinpd.com works, you should be able to know. And yeah, this is the test problem, whether these slides are working fine or not. Who is your favorite cricket player? So this is how it will be. So the problem will be given on the left side and the question will be asked on the right side. You should enter in the answering portion. Okay, once you enter, then I can see your answers here. Okay, I can only see 11, 10, 11 responses. See, those who joined this joinpd.com, please try to answer. If you are unable to figure it out where to answer, just ask me. I will show you how where to answer. Okay. Okay, Steve Smith, MS Dhoni, deleted response. Sanju Samson, Virat Kohli. Okay, fine. Good. So I hope people will be able to answer now. So, and I hope everyone knows where to answer the problem. Okay, let's move to the very first question of today's session. So this is the question we have. Suppose the length of a box is x units and it has a width which is 3 centimeters more than double the length and has height which is 2 centimeters less than the thrice the length of the box. My question is, find the volume of the box in terms of x. Okay, so we have given you the length as x units and we have given the connections between length and width and height and length. So find out how they are connected, how they are related, and you have to find the volume of the box in terms of x. So here you have to choose an option. There are 4 options given to you. So you have to choose one of the options. Okay, I will give you some 3 minutes, 2 to 3 minutes. So those who have seen the graded assignment, you might see this particular question in your graded assignment too. Uh, Divyam Kumar, you shouldn't answer here. Okay, if you answer here, people might see your answer and they will lose in interest to solve the problem. So that is why I request everyone to put your answers in joinpd.com.
Sir, this is my first
Okay,
live,
sir.
so
Acha.
confused about the website.
Acha, okay. So what you have to do is you just open a new tab. So those who are new, I will explain you again. Those who are new to this joinpd.com, what you have to do is you have to open a new tab if you are using a laptop, or if you are using a mobile device, just open a new search for another device and type this joinpd.com in Google, on Google or any search engines. So once you type that, it will ask you the code to join a session, and then you have to type the code VSSHKU. So this is the code you have to type. So once you type this code, you will directly get into these slides. You can be able to see these slides in that site itself. No need to be on the WebEx. So once I shuffle between slides, there also on your screen also the slides will shuffle. So there itself you can answer also. So this is how we can interact, or this is how we will get to know what you gave as the answer. And you can toggle from there. Okay, so joinpd.com is the site, and once you type joinpd.com, VSSHKU is the code. Understood? uh, Kriti, right?
Yes, sir.
Kirti.
Kirti.
Understood?
Yes, sir.
Yeah. Okay. Let me see how many of you gave the answer. 31 people gave the answer. So let me see. Okay, most of you have given 27 as the answer. Very few. One. Okay, two people gave ABC. So I hope everyone know how to do this problem except those five. Let us see quickly then. So once the length of the box is given as x units, and the width we said it is 3 centimeters more than twice the length of the x, then the width of the box will be 2x plus 3 units. So if the length of the box I consider it as x units, the width will become 2x plus 3 units, and the height will be 2 centimeters or 2 centimeters less than thrice the length of the box. So it is 3x minus 2. So now we know the length is x units, width also in terms of x, height also in terms of x we have. So what will be the volume of the box? Volume of the box will be length into width into height. Therefore, the volume of the given box is we have to multiply all these three expressions, x, 2x plus 3 and 3x minus 2. Once you do that, x into 2x plus 3 into 3x minus 2, if you simplify it and expand it, we are going to get 6x cube plus 5x square minus 6x. So the answer will be D. Okay. So now we found out the volume of the box in terms of x. Okay. So question 1 itself, extension of question 1. If the volume of the box is 56, I have given it as 56 units or centimeters, centimeter cube, cubic units. Sorry, that should be cubic units. So if the volume of the box is 56 cubic units, then find the value of x. So now I have given you the volume directly. You have to give me the value of x, which is the length of the box. So I'll give you some 3 to 4 minutes or maybe 5 minutes. So 1820 we will discuss the answer for this. Okay, the people who joined just now, what you have to do is you have to open a new tab and type this, go into this site joinpd.com and type this code VSSHKU. So there you can see the same slides and you can answer there also. Okay. So right now 40 students have joined, and in WebEx I can see 51 students. So the rest 10 can also try to join this joinpd.com. Between why there are only 51 students? Are they celebrating Dasara or what? Any idea?
No idea, sir.
No idea. So have your friends joined this session?
I can see two of them.
You can see few. Okay. So we also pushed the deadline of week 7. Sorry, week 4 to 7th, 7th October. Because as tomorrow is Dasara, we expect many students will celebrate Dasara and might forget to submit their graded assignments. So that is why we just push the deadline of week 4 to October 7, but we are keeping week 5 deadline as it is. So it's on next Wednesday only. So all of you have to do week 5 also before you go to the qualifier exam. Uh, Translation required, Ravi. What do you mean by bolo chi? Is it Bengali?
Yes, sir. It's Bengali.
Okay. So what does that mean?
I don't know exactly what he tried to say. Hello,
He's
Ashi means I'm good.
he's trying to say, let him wait. I'm coming.
Let him wait. I am coming.
Coming.
Oh,
I mean, tell him to wait. I'm coming. Very
okay.
simple.
Doesn't mean that. I'm a Bengali dude. That doesn't mean that. That doesn't mean that.
See,
Hello,
ball.
Achi means I'm
That
good
means
or I'm fine.
that
Ashi
means
means
I'm
I'm
good.
coming.
Sir, I think it is I am good.
I am good. Okay.
Yes, yes, I'm good.
Sir, what is
Oh,
what is saying, sir? Once again, please.
I am good. I am good. Okay. Okay. What about this question? How many of you have given? Only 20 people gave the answer. 21. So are others trying or they just gave up? So apart from this 21, I just wanted to hear from those people who are trying. Are you guys trying to solve the problem or you just gave up and waiting for the answer? If you are just waiting for the answer, I will just move and show the answer to you.
Sir, trying.
Trying?
Submitted the answer already.
Hmm?
Submitted the answer already.
Mm-hmm. Okay. Okay. Those who have submitted, please wait. Those who have not submitted, I'm just asking them, are you guys trying? If you are trying, then I will give you 1 or 2 minutes more.
Sir, please wait. I'm trying.
Okay.
Sir, is this session is not going live?
Uh, I informed them. Can anyone check this? Like, is this session going live?
No, I didn't find the YouTube link or the calendar.
It is not like.
Calendar, but it's live in channel.
Okay, okay. So maybe you just open the IITM BSc channel. So there it is streaming live. Yeah, yeah, I can see it is streaming now.
Yeah, it's live, sir.
Yeah. Maybe they didn't update the calendar.
Okay, sir, no issue.
Sir, on
Okay.
channel it's being live.
Okay. Okay, thanks, sir. Okay. So the time is up. Those who are trying, please try. But I have to move. Okay. Most of you have given two. But let me see what are the other answers. 0.66 and deleted the response. Okay, nice. Okay, so as we know, the volume of the box we have got in terms of x. Here the volume of the box is given to be 56 cubic units. Mind the units, I should have put cubic units. I forgot. I just gave units itself. So the volume of the box is given as 56 cubic units. So that means this 6x cube plus 5x square minus 6x, which is the volume in terms of x, is equals to 56 is what given. Now, whatever this in the second point is actually a polynomial equation. Now it has become an equation and we can solve this equation and find the roots of the polynomial. So once if we try to find the roots, as it is a cubic polynomial, we use trial and error method to get the first root. So if you use the trial and error method starting from 0, 0 will not work. Just use plus 1, minus 1, then plus 2. So when you try plus 2, you are going to get 6 times 2 cube, which is 48, plus 5 times 2 square, which is 20, 48 plus 20, 68, 68, minus 6 into 2 is 12. So it will be 56, 56 minus 56, it will be 0. So therefore x is equals to 2 will be a root. So once x is equals to 2 is a root, we will check for other roots also. As this is a cubic polynomial, we will make sure there are no other real roots. So for that, what we have to do is, as x is equals to 2 is a root, x minus 2 is a factor of the polynomial 6x cube plus 5x square minus 6x minus 56. So once we know this is a factor, if I use the division algorithm, I will get the other factors, which is quotient. Quotient basically the other factors combined. So it will be a quadratic function. So it is a combined of two factors, two other factors. So if you use the division algorithm, then we are going to get 6x square plus 17x plus 28 as the quotient, and that will be another factor. So now we will check whether this 6x square plus 17x plus 28 is equals to 0 is having a real root or not. So once we check, it will not have any real roots because the discriminant, which is 17 square minus 4 into 6 into 28, so which is b square minus 4ac basically, we are going to get it as a minus 383, which is less than 0. So once the discriminant is less than 0, it will not have any real roots. Therefore x is equals to 2 is the only possible value we have. So the answer will be 2. Okay, so that is how you can solve this problem. And yeah,
Sir,
this is
I have a doubt.
hmm.
Sir, just like we have checked that whether this form quadratic equation has a real or imaginary root before
Hmm.
calculating actual root,
Hmm.
is there any method to find whether this cubic equation has a real or imaginary root before finding the root?
See, cubic polynomial will always have at least one real root. This is for sure.
Okay, one real
How?
root is for sure.
For sure. How?
Because it is, I think its range is real. That's why.
Uh, so whatever the cubic polynomial you take, the range will be real. So it will run from minus infinity to plus infinity. So at at least at one point it should cross x-axis, and that will be the root. Okay, for cubic we can deduce this. So for cubic polynomial, there will be at least one real root. So this is what we can find, and for cubic there is no such kind of discriminant thing. Okay, whether to
Yes.
check whether it has only one real root or three real, and also there will not be a cubic polynomial will not contain two real roots, exactly two real roots. Either it will have one real root or three real roots, and this is also for sure. And the reason is very simple. If it has only two real roots, the third one should be imaginary root, and imaginary roots will occur as pairs.
Yes, sir.
Understood? So any cubic polynomial will have either one root, one real root, or three real roots. So this is also for sure. Apart from this, I don't think there is no discriminant kind of thing in cubic polynomial. If there is, we should have studied. So that is one more thing.
Means, sir, we can deduce that any cubic cannot have only two real root. It is
Only two real
impossible.
roots. Yeah.
All other combination are possible, but
Hmm.
only two real root will not occur, and minimum one real root is necessarily occur.
Minimum one real root will always be there, and two real roots, only two real roots will not. So two real roots, one non-real will not happen. Okay. Got the point, right?
Yes, sir, I got the point.
Okay. Okay. So let's move to the next question. So this is a polynomial function given to us. My question is, which of the following statements are correct? Or choose the correct statement. So this is an MSQ, okay? So if your answer is A, B, just type A comma B in the joinpd.com. If your answer is B, C, type B comma C like this. So the four options are: the number of turning points is 5, the number of turning points is 6. In the interval -10 to -5, the function is decreasing. In the interval 0 to 1, the function is increasing. Okay, I will give you a hint also. Just try to plot the graph of the given polynomial, a rough graph. And do everyone know what is turning point?
Yes, sir.
In nature does change, increasing to decreasing or decreasing.
Okay. So when the function value decreasing, increasing also, you know, right? So in which interval function decreases, in which interval function increases. Okay. Then just draw the rough graph of this polynomial, you will get the answer. So I will give you some 4 minutes. 4 plus 1, if needed, plus 1. Yeah, so a question from Kabuto Yakushi. So he was like, okay, if it is 56, it is very easy to break it into x times 2x plus 3 times 3x minus 2. Okay. What if it is not 56? It is something else, like a 3-digit number or maybe 4-digit number. It takes some time to guess the answer. Okay.
Sir, for inflection point, we will not count the turning point, no?
No. See, and that is one more thing. X cube will have 0 turning points. So at x cube curve, at x is equals to 0, it is not a turning point.
And sir, in next quiz, when calculus will be introduced, then we will count that turning point also, right, sir?
No. That is not turning point. That is called a saddle point.
Saddle point.
Saddle point. We will learn in calculus.
Sir,
Okay.
but sir has told that after calculus we will also count a turning point, something like that.
No.
That's
See,
he said
critical.
sir actually told about how to find the coordinate of the turning point where the curve is turning. Sir has said that. Sir had actually said that, not this. What I'm saying.
Okay. So, okay, let me clear it again. So in calculus, we are going to study about the saddle points also. But there is one more thing called critical points. These turning points and saddle points both are called as critical points. Okay, we will include this whatever uh, saddle points we are talking about. We will include this as critical points, not as turning points. So critical points, it are divided into two things. One is turning point and another is saddle point. So these things we will learn in calculus. When the calculus part starts, we will learn them there. Okay, those who have joined just now, just open a new tab and type joinpd.com and enter the code VSSHKU, which you can see on the top right here, and you can answer it. You can answer the questions there. Okay, so what happened here? 38 people out of 53 have already submitted their answers. So the remaining 15, are you guys trying, or shall we look at the answer? Okay, as I already said, silence, I will take it as no. Okay, let's see what you guys gave as the answer. So ACD, AD, ACD, ACD, only B, only B. Oh, all possible combinations I can see here, except ABCD. Okay, okay, ABCD we cannot get because A and B are mutually exclusive events. So anyway, let us see how to do this. As I already gave the hint, to draw a rough sketch of this given polynomial, in order to draw a rough sketch, we need to have few things first of all. So those things are, we need to look at the leading coefficient, which is A. It is given as 1 by 500 in the polynomial. So 1 by 500 is greater than 0. So our leading coefficient is greater than 0. And also we need the degree of the polynomial. So the degree of the polynomial is sum of multiplicities. So it is 2 plus 1 plus 2 plus 3, which is 8. So it is an even degree polynomial. So if the leading coefficient is greater than 0 and the degree is even, then the end behaviors will be, so both the end behaviors will go to plus infinite. So that is for sure. And also we can see the roots of this given polynomial. The roots of the given polynomial are -5, -3, 1, 3. And -5 is repeated twice. 3 is -3 will be repeated only once. 1 root 1 will repeat twice and root 3 repeat thrice. So this is how it is. So once if we have all these things, so those roots which are having multiplicities as even, there the curve will bounce back, and those having multiplicity 1, it will just cut. and those having multiplicity greater than 1 and odd, it will have slightly a bend shape, little turn there. So
So that is
considering
saddle point, right?
those are saddle point, that will be a saddle point. So considering all these factors into this, and we will try to draw a graph, and the graph will more or less look like this. So as this is an even degree polynomial with leading coefficient greater than 0, my end behavior will be plus infinity on both sides. So it will be above. Graph will be above on both sides. And this is the root. These are the roots: -5, -3, 1, and 3. So from here, you can start from -5 or you can start from 3. So let me start from -5.
On
So
rough scale, only this root point will be known, right, sir?
hmm?
On rough, when we draw on rough, because in exam, only roots will be there, right?
Yes,
We will
yes,
be able
yes.
to find out only roots.
Yes, yes, correct. So these things as of now we cannot able to find, but I just clicked it because in order to find the number of turning points. So it just popped up. That's it. So we can draw this graph. We don't know the exact point of this, but we know that there will be a turning in this region. So that is enough. So from here, -5 has multiplicity 2. It is even. So here the graph will bounce back and it will go like this, and it will take a turn somewhere here, and it should reach -3. And -3 has multiplicity 1. So it cuts x-axis and goes below, and it again takes a turn because it has to reach 1 comma 0. So it will take some turns somewhere here, and it will reach 1. And root 1 has multiplicity even, so it will bounce back again. So it won't cut, it will bounce back again. There will be a turning there also, and after that it will be like this, and it should reach 3 comma 0. So it will take a turn here, and again it reaches 3, and 3 has degree 3, sorry, multiplicity 3. So therefore it will take an some shape change, but it cuts x-axis. It will not bounce back. The shape might change, and it cuts x-axis and it goes like this. So there
Sir,
will be a
sir, for multiplicity, sir, it should be even, then only it will bounce back.
yes, correct. So when the
Sir,
multiplicity
three,
even, yeah,
at 3 saddle point or critical point, we can also say critical point, right?
yes, 3 is a critical point, but as of now we never dealt critical points, right? So in week 7 and 8 we will talk about critical points, but as you said, this is a critical point. Okay.
Yes, sir. Yes, sir. Okay, sir.
So this is a critical point, but this is not a turning point. So these points we call it as saddle points, where the nature will not change. Turning points are only points where the graph takes, and the nature of the graph changes from increasing to decreasing or decreasing to increasing. So here these points are called. So at -5, the graph will be decreasing, will go from decreasing to increasing. So it will take a turn and it will change the nature of the curve. And here also it is from increasing to decreasing. Here also it is decreasing to increasing. But here you see at this particular point, it is increasing, and after that point also it is increasing. So this is not a turning point. So the only turning points we have are this point, and this and this. So there are 5 turning points, and then there is option C and option D. Option C says in the interval -10 to -5. So in this interval, the graph is decreasing. So is the graph decreasing or increasing in this interval?
It
-10
is
to -5.
decreasing,
Decreasing,
sir.
sir.
It is decreasing, right? So as x increases, my y value decreases. So it is decreasing. And from 0 to 1, what is the nature of the curve? It is increasing,
Sir,
right?
on
From
seeing graph, it is increasing, but on paper, how will we define? Because this turning point, which is at the bottom, it could also be in fourth quadrant
It could also
on
be in
graph
the.
paper. We
Okay.
cannot decide. Yes, sir.
Yes, sir.
It can also be in fourth quadrant or third quadrant. How we will decide?
Okay. Then you can define it using the y-intercept by substituting x is equals to 0.
Sir, but how y-intercept will be decided? Y-intercept, how can be possible, sir?
Uh, Sir, we can also
Okay.
define it
Okay.
from the end behavior of the graph.
No.
I think
I
for
hope. I
that
hope
we need
your
to
point is
calculate
valid.
bottom point. We need to use
Hmm.
calculus.
Right. Correct. So, okay, I understood your point.
Sir, we can check for -1, and if it is lesser than, then we can say.
Yeah, that is one more thing you can do, but
It is
that
continuous,
takes a lot of
not
time.
discrete.
No. Check for -1, check for 0, and check for 1. Then you will get to know whether the graph is increasing or decreasing.
Sir, but these are discrete points, sir. How can we say by just saying checking on discrete points?
See, how can you say is because let me just stop this streaming and let me just go.
I think for we have to check at 0 and just below 0, so that if
Below
there
0
is
means
decreasing.
it is 1, right? You can check for 1, -1 also.
Yes, sir. But we need to also check for 0.5 if it fails.
If it fails, you need to check for
0.5 also.
uh,
It might be fail, so no, sir, because there are infinite point.
uh-huh. Just a second. Okay, this is something interesting thing we can do now. Let me share my screen.
Sir, there will be only
There will be only
one turning point, so we can say that after that it will be increasing, and before it will decreasing, like this.
uh, okay. So do we know p of x is continuous? Matlab, there are those who don't know what is continuous. It means there are no breaks in the graph. So you can draw without removing your pen. You can draw the whole curve.
Yes, sir.
Okay. So once p of x is, you can draw polynomial curves very smoothly and without breaking. So
It's called continuous graph.
you check the value of f of -1, f of 0, and f of 1. Okay. If f of -1 is less than f of 0 is less than f of 1, then I can say in this 0 to 1 interval is uh, increasing, where given so I'm getting an echo. Can someone please mute yourself? uh, Given that in between -1 to 1 there are no roots. So if this is given, and if we can get this signs, so that means the value of this function is of -1 is somewhere here, and 0 is greater than f of 0 is greater than f of -1, and f of 1 is greater than f of 0. So it has to pass through 3 points, and the curve is smooth, so it will definitely have to go like this. Okay. If this is not true, if this is true, f of -1 is greater than f of 0, and f of 0 is less than f of 1, then the curve is something like this. This is red thing, let us say this. So f of minus 1 is greater than f of 0, and f of 0 is less than f of 1. Then we cannot say that okay, the curve might come like this and it can go like this, or it can come like this and go like this.
It's down parabola, sir.
It might be turn at exactly at y-intercept also.
It might turn at exactly at y also. If it turns at okay, it might turn at exactly at 0 also. In these cases,
But
when
I
in these
think
cases,
in blue case, it will be impossible to figure out whether the D point is correct or not. Right, sir?
why if this is a turning point, when you substitute x is equals to 0.
Sir, but I will
Okay,
not be sure whether it will be
yeah,
turning point or not.
yeah. So this is very bad situation. We can say bad situation, and these bad situations occurs only when in these cases. So when your left side of 0 point, whatever the point you take on the left side of 0, if that value is greater than 0, f of 0, then only these red, green, blue cases arise. If the situation is like this, f of minus 1 or f of minus 0.5, whatever, if at least one point left side of 0 has value less than f of 0, then the case will always be like this only, the black curve. Okay, given in the interval minus 1 to 1 there are no roots. So as there are no roots, there is no need to cut x-axis, and passing through three different points, there will be only unique, not unique, there will be only one way possible, one graph possible, and it is an increasing graph. Definitely in that region it will be increasing. Okay, or yeah, there can be another possibility also like this. It can go below and it can come like this. But in both cases, 0 to 1 will be an increasing function. Okay, by like this you can check, but yeah, so I shouldn't have
Yes, sir,
asked
we
in
can
that
check.
interval.
If at minus 1 it fails, we should go to 0.5 and down and down.
So like that you can check. Uh,
Okay, got it.
so like this, I shouldn't have given from 0 to 1. Maybe I should have asked from maybe 4 to some 10. So that is for sure. It is an increase. Okay. So if you do like this, then yeah, this is the rough graph. This is not the rough graph. This is actually the exact graph. I have taken it from Desmos. So if you draw the rough graph, we can check like that, and we can conclude that even 0 to 1 also it is increasing. Therefore, from the rough graph, what we can say is the number of turning points is 5, and in the interval minus 10 to minus 5, the function is decreasing, and the interval 0 to 1, the function is increasing.
So,
Hmm.
so how will we get to know the number of turning points is 5 from a rough graph?
So wherever the curve changes its nature from increasing to decreasing and decreasing to increasing, those are the only points. So the curve should pass from minus 5 to 0 and minus 3 to 0 also, because minus 3 is a root.
So we
So
should find out the roots and then plot the graph.
see, that is what, right? Our step one is you have to find out the roots and the multiplicities of each root, degree of the polynomial, and leading coefficient. So leading coefficient and degree will help us to identify the end behaviors. So left side of minus 5 and right side of 3. So how will the graph be? Whether it will go to plus infinite or minus infinite. So with that we can say both will go to plus infinite. From there we can draw the graph. The multiplicity of minus 5 is 2, so it will bounce back. So the curve at minus 5 will be like this, and once it is in this direction it should reach again to minus 3. So at least at one point it should take a turn. So it will take a turn at any point. We don't know what exactly the point is, but we know that minus 5 to minus 3 there should be a turn. Like that we can find. So there should be a turn here, turn here, turn between 1 to 3. So 1 comma 0 to 3 comma 0 there should be a turn. So these are the three turns, and minus 5 and 1 there are bounce backs. So they are also considered to be as turns. So there will be a total of 5 turns.
Can we consider the number of turns the polynomial will have? The number of slopes 0 will be equal.
Number of slopes 0 will be equal, will not give you. See, at this particular point, so whatever the saddle point we are talking about, even there the slope is 0.
Also at minus 3.945.
See, these are turning points anyway. The slope here, 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 and here will be 0.
Yes, sir. That's
But
what I am saying. Roots should
in
not be confused.
in addition, here also you will get the slope to be equal to 0.
Sir, but from that point, sir, sir, only one point it is the line is passing through only one point on the x-axis, sir.
Hmm.
So then how can the slope be 0, sir? It will
Because that
tend
is
to
why they are called saddle points. For example, I will just give you an example. Take the x cube graph. X cube.
Okay, sir.
X cube at x is equals to 0 has slope 0.
Yes, sir.
Yes. But
Yes, sir.
x cube at x is equals to 0 is not a turning point. So that is how we named a new name called saddle point.
Okay, sir. So
Actually,
then
sir,
how do
in
we find
calculus,
saddle
it is
points while we draw, sir,
At that
figure
it is 0, sir.
ourselves?
Hmm? How
Sir,
to?
when we find out the roots and draw the figure in sir rough
Hmm.
for solving questions, sir, can
Hmm.
we identify the saddle point there?
Of course, you can identify a saddle point there. Not saddle point. You can identify what are all the turning points are there
sir,
from a rough graph.
all odd degree other than
Hmm.
one gives saddle point at
Yes.
roots.
Yeah.
And sir, if this type of turning is above the x-axis, then also it is saddle point.
Then also it is saddle point.
Okay,
So
sir.
you are referring something like this, right? If it is like this, can you see my cursor?
Yes, sir. Yes, sir.
So something like this. If you see somewhere in the first quadrant, if you see this shape, then also it is saddle point only.
Sir, but how to know it is increasing or decreasing? I mean, where is the starting and where is the ending?
There is no starting and ending. See, just the left side. You look at the left points of that particular point and right points of that particular point. Very nearer to. So that is where the calculus comes. When we go deeper, when we look at delta distances,
Okay. Yeah.
okay, very small distances, this calculus arises.
Sir, in
Okay,
the interval minus 10 comma minus 5, there can be also decrease, no sir? Increase, no sir?
where, how?
Just we are considering from minus 5, we are just seeing near, like closer to minus 5. In minus
Huh.
10, minus 10 comma minus 5, there can be also decrease and increase, no sir?
Okay, if there is a bend, then it should come and cut x-axis and it should be having a root.
Yes, sir.
But there are no roots, right? So the only roots are minus 5, minus 3, 1 and 3. That's it. This
No,
particular
sir.
polynomial.
Understood in the interval minus 10 comma 5, we can have some other like upward parabola which connects this point, which connects the starting of graph.
That is going to infinity, not possible.
That will not go, right? See, the given graph is this. The given equation is this. And
Yeah.
whatever the bends and everything will happen around this only. Plus 5, plus 3, minus 1 and plus minus 3.
So we do not consider minus 10 regions, and minus 10 to minus 5 region, we only consider till minus 5.
See, left side of the leftmost root, it will follow the same behavior throughout the end. So leftmost root is minus 5, right? Leftmost root. So
Yeah,
if you
sir.
order your roots in order, minus 5, minus 3, 1 and 3. So left side of leftmost root and the right side of rightmost root, it will have the same nature. If it is increasing, it will increase till infinite. If it is decreasing, it will decrease to minus infinite throughout. There will not be any bends. So that is why they are called end behaviors. So we look at the end behavior. So till infinite, it will be like this only. If there are some bends and curves and everything, we would have studied that also.
Okay, so till like it is going to be infinity end behavior.
See, from minus 5, so it will go to plus infinite as x goes to minus infinity. So it will go like this and it will never bend, or there will not be any bendings. So it will go to plus infinite.
Yeah,
On
okay,
the
sir.
right side also it will go to plus infinite. There will not be any bends. So we no need to worry about bends that are left side of leftmost root and the right side of rightmost root.
There will never be any bends, no, sir?
There will not be any bends. So this is how the polynomial graphs looks like.
Yeah, sir, I got it.
Okay. Yeah. So whatever the
Sir,
bends or saddle points, everything happens in between the leftmost root and the rightmost root.
So can you explain me about end behavior?
So end behaviors means how the graph will behave. So whether my polynomial value will go to infinite or minus infinite as x goes to infinite or minus infinite. So if you see here in this particular polynomial, just a second, I will just open it. Let me show other people the next question. By then, others please try this question. So those who have understood about question 2, so this is the function given to you, which is the best fit of the data, which is given in the table 1. So we have 4 data points, and the student predicted that this particular function is the best fit, and the value of c is unknown. Now our question is, what should be the value of c such that the sum squared error SSC will be minimum. Okay. So you can see this question in joinpd.com. I'm just stopping the streaming, stopping the sharing here, and I'll just open another. Journal screen. So those who are asking about the end behaviors, so end behaviors are what happens when x tends to plus infinite and when x tends to minus infinite. What happens to p of x? So will it go to plus infinite or minus infinite? Okay, this is what end behavior. So what we do is, how do we check is, so if I have any polynomial like this, x minus x plus 5, x plus 3, x minus 1, x minus 3. Okay, if this is a polynomial of degree 4, a polynomial of degree 4, I just wanted to check what happens to this polynomial value when x goes to plus infinite. So as x is going to plus infinite, so you see this value will also go to plus infinite. As x is going to plus infinite, this value will also keep on increasing and it will go to plus infinite, and this also goes to plus infinite, x plus 3. This also will go to plus infinite, and this also will go to plus infinite. So as I keep on increase my value of x, this value will increase, this value will increase, this value will increase, this value will increase, and the total product will increase, and it will also go to plus infinite. So as
So,
x tends,
so it means that we are substituting the value of x, right?
okay, we cannot substitute infinite, right?
Yes, yes.
So we check like this. If x tends to infinite, that means if x takes larger and larger values, so something like 100, 1000, 10,000, 1 lakh, 10 lakhs, and then 1 crore, 10 crores, like this. So if my value of x is increasing, what is happening to my polynomial p of x? Is it increasing or is it
Yes,
decreasing? So
it is
that is what,
increasing.
and yeah, it will increase because there are 4 terms here, and all the 4 terms will be increasing terms, and if I take the product, it will increase. So I say as x tends to plus infinite, this will go to plus infinite.
So
Now
x is directly proportional to the function, right?
x is directly proportional to the function. No, right? X power 4 something is directly proportional to this.
Yeah.
X is not directly proportional.
Okay.
Okay, that you
Yes.
will see here now. You will get to
Okay.
know as x goes minus infinite now. So now I am approaching to minus infinite. That means I am decreasing the value of x. So that means I am going from minus 10, minus 20, minus 100, minus 1000, minus 10,000, minus 1 lakh, like this. What happens to my p of x? Whether my p of x also decreases or it will increase. So that you will get to know now. So as x tends to minus infinite, you see, let me use another color now. So this x plus 5 term, x plus 3, x minus 1, and x minus 3. So as x is tending to minus infinite, that means x is taking smaller and smaller values. Even this x plus 5 will tend to minus infinite. Yes or no?
Yes, yes.
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 Similarly, this x plus 3 will also go to minus infinite.
Yes.
This will also go to minus infinite. This will
Yes.
also go to minus infinite.
Sir.
But this is a product of 4 terms.
Yes.
So this is a negative term. This is a
Yeah.
negative term. This is a negative
Yes.
term, and this is a negative term.
But product will be
Product,
positive now.
product of 4 terms. What happens to the product?
It will be positive.
It will be positive, and if I negatively, it is matlab, if it is decreasing,
Yeah.
if I remove the minus sign, it will increase, right? The value
Yes.
will
Yes.
be larger.
Yes.
So that
Yes.
means it will tend to plus infinite.
Yes.
So now you see, even though my x goes to plus infinite, or even though my x goes to minus infinite, my p of x will go to plus infinite.
Yes. Yes.
Correct? So
Yes.
those are called n behaviors, and on graph, this is how it will be. So on graph, what happens is, so the roots are minus 5, minus 5, minus 3, 1, and 3. So the end behavior starts from the left side of leftmost root and the right side of rightmost root. So from 3 you start. So you keep on increase your value of x. So if I increase my value of x, what happens to my p of x? It will also increase. This is how it is. And from left side of leftmost point, I will decrease my value of x. So from minus 5 to minus 10, minus 100, minus 10,000, like this. So if I go like this, my product, so this value is negative, 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 but my product will be positive.
Yeah.
So how much I decrease my x, that much my p of x will increase. Correct?
Yes. Yes.
Yes. So even from the left side of minus 5 also, the graph will go like this. So if I move, if I decrease the value of x, my y value will increase. My p of x value will increase and go to infinite. This is how the end. So these are the end behaviors.
Then in that, what about the turning points? In
So
particular, this.
no. There will not be any turning points to the right side of 3 and the left side of minus 5.
Okay.
If the polynomial equations are given like this, like this. So if you
Okay.
can see the roots, multiplicities, and everything.
Yes.
Okay. If
Yeah.
this is given, there will not be any turning points to the left side of -5 and the right side of +3. So this -5 and +3 are, if you order your roots in ascending order, this -5 is the least root, this 3 is the highest root, greatest root.
Okay. Yes, yes.
So the left side of -5 you will see the end behavior nature, and the right side of 3 you will see the end behavior nature.
So,
Okay, whatever happens, the turning points will happen in between. So at
okay.
3 there can be a turning point, at -5 there can be a turning point, and the saddle points or cutting or whatever happens in inside the interval -5 to +3 closed.
Okay.
Okay.
Sir, one more question is that as you were telling that for x cube there will be no turning points,
Right.
right? So if so, when I was watching a video, so sir was telling that so whenever we are having a degree and we find out the turning points, we use a formula called n-1.
No. At most n-1.
Okay.
So there is something called at most thing. So at most n-1 means it can have n-1 or less than n-1 also.
So then for how x cube turning points will be 0?
How means the only you can see the curve, right? By looking
Yeah.
at the curve, or so if you see the curve, it will be like this. Okay. So maybe if you think this is the turning point, okay, so this is the only place where it can have any critical point or turning point, correct? Other parts are very smooth.
Yes.
So
Okay.
this is x cube, and now we are interested to check whether this is turning point or not. So firstly, what is the definition of a turning point? This is how we define: the graph will either change from increasing to decreasing, or decreasing to increasing. Okay, so at that particular point, so at that point the graph will either change the nature, you can say will either change the nature from increasing to decreasing or decreasing to increasing, such as if it is increasing it should decrease, so this point is called turning point, or if it is decreasing from that point it should increase. Okay, these are called turning points. So this is how we define turning point. So the turning point, before that if it is increasing, after that point it should be decreasing. Before that point if it is increasing, after that point it should decrease. So the nature of the curve should change. Those points are called turning points. So this point and this point are called turning points. Okay, now if you see this particular point, the left side of that point the curve is increasing, so this is an increasing curve right here, and after that point also the curve is increasing. Okay, there is no change in the nature of the curve. Before also it is increasing, after also it is increasing. Did you understand this?
Yes, yes.
So it didn't change the nature of the curve, so those points are not considered as turning points. So we consider those points as turning points where the nature of the curve changes. Okay, and if you know calculus, I'll just give you, if you know calculus, if f of x at x is equals to x naught is turning point if f dash of x is 0 and f double dash of x naught, sorry, f double dash of x naught is not equals to 0. So if you understand, take it. If you don't understand, it's fine. Hello.
Sir, can we say that x coordinate of turning point will be more closer to the root with lesser multiplicity?
X. Can you repeat?
X coordinate of turning point will be more closer to the root with lesser multiplicity.
Root with the lesser multiplicity.
Yes,
Oh,
x coordinate of turning point will be more closer to that.
Okay. This is a new thing. Will it always work?
I don't know, but in equation second, I think it is working.
Which equation?
Equation second.
Okay. Which has lesser multiplicity, you said, right? Which has less multiplicity.
Sir, actually he's saying that uh, the वो ये कहना चाहते हैं कि झुकाव किस तरफ होगा सर टर्निंग पॉइंट का
हाँ.
Yes, sir.
I'm getting that, but let me think. It will not work. So what is the accuracy or what is the reliability of your statement? So whether it is 100% true?
Sir, I think if there is two roots, -3 and suppose -2 and +2, so this statement can tell whether the turning point is between -2 to 0 or between 0 to +2.
Right. So that
Yes,
should
sir,
be symmetric. Right? Symmetric roots होना चाहिए पहले. That means it should be if it is +1 and -1 or +2 and -2 like this. Or
Sir, please discuss the question 3. We have solved it.
Okay, yeah. Let's come to that.
15 minutes has gone, sir.
Yeah. Let's come back and let's solve that. Let me share that screen. At the end of this session, we will try to check who said that thing, like किसका multiplicity कम हो उसका side हो. So whoever said, just wait for 5 minutes after the session. We will just verify. We just take few examples and we try to analyze few things. Okay. Yeah. Only 19 people answered. Okay. So we should talk about this question more then. So what is the question saying? So we have given a data, 4 data points, and there is a student who came up to fit this data, and he has given the equation as f of x is equals to x minus 1 into x minus 3 into x minus 5 plus c. So he don't know what is the constant, but he has given this. We should find the value of c such that when I compute the sum squared error, if you remember, we studied this in week 2. So sum squared error should be minimum. For what value of c this particular sum squared error is minimum. So let me see what all the 20 people gave. So 4, 6.25, 6.25 बहुत लोग हैं.
Only I have given 0.
Okay.
But all answers are different.
I can see. Okay, those who have answered 6.25, can I have some explanations from your side? Can I listen some explanations from your side?
Sir, from where to open this question?
Sir, you are not audible, sir.
Am I not audible?
Yes, sir, you are audible.
Okay, I am audible. So you just join this joinpd.com. Those who have asked now that where can we see these questions, open the joinpd.com and type this code right top right VSSHKU. You can see the questions.
You are muted, sir.
Am I muted? No.
No, sir, you are audible.
Now you
I am
are.
audible. Okay. Okay. Is my screen visible?
Yes, yes.
Right? Okay.
Sir, can you
Okay.
tell from where
What
to
am I?
open this?
Okay. What I already said. You just open a joinpd.com. Open a new tab and type joinpd.com and type the code which is visible on the top right. VSSHKU. So you can see the slides there.
Okay, sir.
Okay. Okay. And also I asked whoever gave 6.25. I just wanted to hear the explanation from one of you. How did you solve and how did you get 6.25 as the answer? Because I can see most of you have given 6.25.
Hello, sir.
Yeah.
I have just putting the given x value in the equation and given y minus finding y by putting x in that equation and the square of both.
Mm-hmm.
And I find
Mm-hmm.
the equation
Okay.
and after that I find the minimum value of that by x equal to minus b by 2a by putting this formula. And I get
Okay.
6.25.
Okay. Correct. So when we substitute 4, what we will get? 3, 1 and minus 1 minus 3. C minus 3 minus 10. Okay. Okay. Even I did wrong. So even I might have drunk. Okay. Now I wanted to listen those who have given 4. So anyone who have given 4, can you give me some explanation about this? How you got 4?
Sir,
Hello.
I have put value of x in the equation, and
Hmm.
it's compared to the y value.
Uh,
That's now I got c is equals to 4. So I got for the first 3 numbers of c value is 4 and the last number is 13. So that's why the 4 is a minimum c value.
okay. Okay. No, 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 no. Even I have done wrong. So what I have done is the last thing I have done. I have taken it as c plus 6. It is we are going to get c minus 4, right? C minus 3.
Yes,
This value. C minus 3, right?
yes,
Yes,
sir.
C minus 3.
Yeah, yeah, yeah. So this is not c minus 4. My intention was to give in order to get 4 minus c square, but I made some silly mistake of taking 3 times 2. I have taken 3 times minus 2. So it is 3 times minus 1. Okay, so you have to excuse me for this wrong answers. I will just update these slides and I will upload. And yeah, in that case, let me stop this thing and let me go to the journal screen. Okay, is my screen visible now? This journal screen?
Yes.
Yes, sir.
Yes, right. So the values, so the data given is like this, and y points, xi's and yi's. So this is given to be 4, 4, and this is given to be 7, and this is given to be 10. So we have to find the SSC. So SSC is basically summation I is equals to 1 to 4 yi minus f of xi ka whole square. So this is error of each data point, and we are going to square that error, and we are going to sum all the squared errors. So that is what sum squared error means. So so f of x is given to be something like this. Okay, now each and every point if I take, so y1 is 4 minus f of 1, so f of x1 xi, so it is 1, so f of 1, it is, this is 0 and this is c, so this will be 4 minus c whole square. And for the next point also we are going to get 7 minus, if I substitute 2, this is 1, this is minus 1, this is minus 3, so that will be plus 3, so c plus 3 whole square plus 4 minus, when I substitute 3, this will become 0, so it will be c square. And finally the last point, if I substitute 4, this is 3, this is minus 1, sorry, this is 1, this is minus 1 plus c, so this will be c minus 3, so this is 10 minus of c minus 3 whole square. So from here 3 times 4 minus c whole square, so everything will be 4 minus c plus 13 minus c whole square. So this is the SSC we got, and if you expand this, we are going to get a quadratic equation in terms of c. So 3 times 16 minus 8c plus c square plus 169 minus 26c plus c square, and this is 48 minus 24c plus 3c square plus 169 minus 26c plus c square. And if I add this, I'm going to get 217 minus 50c plus 4c square. So this is a quadratic equation in terms of c, and as the leading coefficient is greater than 0, this is an upward parabola. So we are going to get an upward parabola. If I draw the curve of this graph of this given quadratic function, we are going to get an upward parabola, and the minimum will occur, SSC value minimum will occur at the vertex point. So we just have to find the vertex point. So the vertex point will be occurring at minus b by 2a. So minus b is minus 50 divided by 4, 2 into 4. So this is b, this is a. So from here 50 by 8, we are going to get 25 by 4, which is 6.25. So 6.25 is correct. So those who have given 6.25, it's correct. Any doubt? So this is how you have to do whenever an SSC problem is given. So we can fit our data into any curve. So this is a polynomial curve. In week 2, we just saw only a straight line fit. But week 3, there is quadratic fit. This is polynomial fit. Even in week 5, week 6, we are going to see exponential and logarithmic fits. Okay, whatever the predicted function is, you no need to worry. So look at the data, given actual data values. So these are the compute the predicted values for the given exercise. So actual minus predicted whole square and add all the errors. That's it you have to do. So you will get an SSC. So that is what SSC is. So maximum minimum based on the quadratic properties we have, we can decide for what value of C this particular SSC will be minimum or maximum, like this. Okay. So 6.25 is correct, and even I am wrong. So this is why you shouldn't do things in hurry. So I just made these slides 1 hour before the session. Okay, so whatever I gave is wrong. 6.25 will be the answer. Okay, try to solve this question now. So this is a contextual question. Some context is being added to our mathematical expressions. So the Ministry of Road Transport and Highways wants to connect 3 aspirational districts with 2 roads R1 and R2. 2 roads are connected if they intersect. Okay, so we say 2 roads are connected if they intersect. The shape of the 2 roads R1 and R2 follows polynomial curves. So the shapes are also given to us. So one road follow f of x is equals to x minus 11 whole square into x minus 13 whole square, and g of x is equals to minus of x minus 11 into x minus 13, which is a quadratic function. Given g of x is a quadratic function and f of x is a polynomial. Okay, so the question is, what will be the x coordinate of the third aspirational district if the first two are at x intercepts of f of x and g of x? Okay, we have given that the first two are at x intercepts of f of x and g of x. What will be the x coordinate of the third aspirational district? Okay, so hint is also given to you. The coordinates of the aspirational districts are at the intersection point, so you have to find the intersection points. So the intersection points you can get by equating those two functions. So f of x is equals to g of x, you can get the intersection points, and out of all the intersection points you get, you have to exclude the intersection points which are at x intercepts, because first two are at x intercepts. So you have to enter a number. Okay, so take some 4 to 5 minutes time.
Sir, hello.
Yeah,
Sir, it is the same question in my GA.
it is the same question.
Yeah.
Values also.
Yes, sir.
Then you are
Function is
lucky,
same.
man. See, this is just the parameterized question. Okay, some people might get the same question. I just only change the values, that 11, 13. So that 11 and 13 are different to different values for some different people. But it's okay anyway. If you know how to solve this, whatever the values are there, you can solve for other people can also solve it. It's fine, not an issue.
Hello, sir. Hello.
Yeah.
Sir, I am asking that this question say there are two roads and their path is represented by fx and gx. And all the intersection points of these two curves represent a district in which two districts are at x intercept and one unknown districts we have to find out.
Correct. X coordinate of the only the x coordinate I need. Okay.
Sir.
So you are going to get a point, 3 points, 3 intersection points. Okay. The other hint is there will be 3 intersection points, out of which 2 will be x intercepts of f of x and g of x, and the third one you are going to get as a point. So there will be x coordinate and the y coordinate to that point, but I just need only the x coordinate. Okay, let me see how many of you have done. 16. So are others trying? So do you require some more time, or you just wanted to see the answer?
Done, sir.
Done. Anyone who haven't done and still trying? If you say yes, then only I can wait. If you are silent, I will just take it as no and I will just discuss the answer. Okay, silence again. Okay, fine. Fine then. Let me see what all. Those who have given, they have given 12 as the answer. Okay, fine. So 12 should be the answer. So what we have to do, we have also given the hint. So the very first step is, as the two roads are connected, these two roads will connect when f of x is equal to g of x. So when we equate f of x and g of x, we will be getting the x coordinate of the third aspirational district. So when we equate, f of x is given as x minus 11 whole square and x minus 30 into x minus 13 whole square, and g of x is given as minus of x minus 11 times x minus 13. So if I bring that x minus the right side part to the left hand side, and I can take common, I can take x minus 11 into x minus 13 common from both the terms. If I do so, I'm going to get like this: x minus 11 into x minus 13 of x minus 11 into x minus 13 from the first term and plus 1 on the second term, in the second term, and this is equals to 0. So if you expand this, x minus 11 into x minus 13, so we are going to get x square
minus 24x plus 143.
Yeah, minus 24x plus 143 plus 1, it will become 144. So x square minus 24x, so 24x I can write it as 2 times 12 times x, and 144 as 12 square, so it is in the form of a square minus 2ab plus b square, so I can write it as x minus 12 whole square. So finally, if you simplify, we will be getting like this: so x minus 11 times x minus 13 times x minus 12 whole square is equals to 0. So from this, we are going to get the roots as 11, 12 and 13. But what we said, if you can see closely, the x-intercepts of f of x and g of x will be at x is equals to 11 and x is equals to 13. So the two x-intercepts will be at 11 and 13 for f of x and g of x, for both of them. So just if you can draw the rough graph also, it's fine. Or if you can see, for g of x, it's a quadratic function. The quadratic function will have x-intercepts at roots, and the roots are x is equals to 11 and x is equals to 13. From there also you can get. So as these two 11 and 13 are the x-intercepts, the leftover is 12. Therefore, x is equals to 12 is the x coordinate of the third aspirational district. Okay, this is how you have to do. So those who have got the exact values, so you got an free 1 mark. So what you have to do is you have to just substitute this 12 in your graded assignment. Okay. Yeah. So yeah, I have one more question, but this time we have removed this question from our graded assignment, I guess. But this is very interesting or challenging type of question. That is why I kept as it is. See, it is given that this question, it is given that m and p are the roots of the polynomial x cube plus 5x minus 10. Okay, and the sum of the roots is 0. So again, there is an error. There shouldn't be question mark here. So find the value of m cube plus n cube plus p cube. So I will just check how quick you can do. Okay, I will. Those who have done within 2 minutes, I need an explanation. Those who have taken 4 minutes, I need an explanation. Those who have taken some more than 5 minutes, I will ask for an explanation. Okay, there are 3 or 4
Done,
ways
sir.
to do. Done.
Done, sir.
Okay. There is a smart approach for this. So we will discuss, and I will ask from you guys also. Those who have done within 1 minute, I will ask you people. So those who have done within 1 minute, just raise your hands if it is possible in WebEx. I will just call out few names. Is there an option like that in WebEx?
Yes, sir. There is a,
Yes, right? Yeah.
there is an option.
Right. Okay. Okay, let me give you two minutes. Those who have done within 2 minutes also, it's fine. You guys please raise your hands.
Excuse me, sir.
Yeah.
Yeah, sir, can you please explain the previous question?
So that aspirational district
Yeah,
question, is it?
yes, yeah.
Okay. Maybe after 5 minutes, let me discuss this problem also. I'm done with the agenda for today. Then I will just
Okay,
go
sir.
back and explain that question. Okay.
Okay, sir.
Yeah.
Okay.
Okay, then I have given 4 minutes and only 15 people answered. And that too 30, 30 minus 30, 0, 0. I can see most of you have given 0 as the answer. Okay, let me call out the names then. Okay, Avinash.
I think I just realized I have given wrong answer.
Okay. Ritik.
Actually, sir, I have used the formula x cube plus y cube plus z cube is equal to 3xyz,
ABC. Okay.
and product of roots is plus 10. So I have multiplied 3 times 10, 30.
Okay. J- Sayan.
Sir, since it is a polynomial, so I assume that f of x or p of x, whatever that is,
Hmm.
is equal to that x cube plus 5x minus 10. Then
Hmm.
there are three roots, m, n, and p. So f of m, that would be 0. So m cube plus 5m minus 10, that is equals to 0. Same
Hmm.
for n and p as well. And
Hmm. Hmm.
I just added the three, the p of m, p of n, and p of p, that is equals to 0. So I got like m cube plus n cube plus p cube plus 5 into m plus n plus p, which is 0,
Hmm.
the,
Hmm.
the summation of the root, and minus 30. And that entire thing is equals to 0. So at the end, if we just equate that, we get m cube plus n cube plus p cube equals to 30.
Okay. Okay, very good.
Thank you, sir.
Yeah. Correct. Whatever
Sir, I
science
have also did
approach.
this.
Yeah, yeah. So whoever followed science approach, good. I appreciate that. And even Hrithik's also, if you remember that formula, it's okay, fine. But we don't need that formula here. We just need the application of this roots and polynomial. As we have said that it is a root, so whatever he said, f of m, f of n, f of p should be equal to 0. So m cube plus 5m minus 10 is equals to 0, n cube plus 5n minus 10 is equals to 0, and p cube plus 5p minus 10 is equals to 0. So even if I add all the three expressions, I'm going to get it will be equal to 0. So from first terms, it will be m cube plus n cube plus p cube, and the next terms are 5 times of m plus n plus p. So m plus n plus p is the sum of the roots, so it is 0, and minus 10 minus 10 minus 10, it will be minus 30 is equals to 0. And from there we can say get m cube plus n cube plus p cube to be equals to 30. So this is, so if the idea got striked in your mind, it will take only 1 minute, not more than 1 minute. Even if you remember the formula, and if you try to recollect the formula, it might take 2 minutes or less than 2 minutes. But if you sit and try to get the roots, something like if I said m and p are the roots, then if you just start with trial and error, so within 4 hours of your qualifier exam, you will end up wasting your time there, and even then you will not get the answer. So there are few questions where logic is more important than mathematical knowledge. Including mathematical knowledge, there should be some logical knowledge also. How should we approach the answer in order to get, how should we approach the question in order to get the answer quickly? Okay. So yeah. So this is all I have for today. Thank you so much for joining, and this is the session I felt like it's more of like very silent, with wherever you have to speak there you spoke, and the rest of the time you just been quite patient. I appreciate that.
Sir,
Thanks a lot. Yeah.
last sum, can you please explain with the formula, sir?
Explain with the
Formula.
formula is, if the sum of the roots are 0,
Okay.
then uh, if a b c are the roots, then if a plus b plus c is 0, then a cube plus b cube plus c cube is 3abc. And from the given equation, in the given equation, this is the product of the roots. 10 is the product of the roots. So ABC is the product. So 3 times 10, it will be 30.
So minus 10 is the product.
Okay, sir. Thank you.
Minus 10 is the product, not 10.
Minus 10 is the product, no? Not 10.
Achha, minus 10 is the product.
So
Product
10 is
is
the
minus
product.
10, no?
No,
It
10
is
is the
not
product, right?
quadratic. It is not
See,
quadratic.
this is not quadratic. See, in x cube there is x square term missing here. X square term will be minus of that will be the sum of the roots, and this is product of all possible two combinations. This is equals to 5, and the product of roots ABC will be minus of this. Okay. Those who don't know the formula,
Can you please give me the formula?
so you just want only formulas. That's it, right?
No, because I thought it was a cube plus b cube plus c cube minus 3abc is equal to 0.
Okay. See, whatever you thought is correct, but you should also know what is your ABC. See, if x cube, see ax cube plus bx square plus cx plus d. If this is the polynomial you have, sum of the roots. So, okay, alpha beta. If I say alpha beta gamma are the roots, alpha plus beta plus gamma is minus b by a. Alpha beta alpha gamma beta gamma is equals to c by a, and alpha beta gamma will be minus d by a. Okay, this is how it will be.
Okay, the formula is
If it is ax power 4 plus bx cube plus cx square plus dx plus e, if it is like this, then what happens? Then if I say alpha beta gamma delta, then alpha plus beta plus gamma plus delta will be minus b by a, and alpha beta alpha gamma alpha delta plus beta gamma beta delta and gamma delta will be c by a. So alternatively sign will change, minus plus, and then there is alpha beta gamma plus alpha beta delta plus beta gamma delta plus. So one more thing is alpha gamma delta. This will be minus d by a, and alpha beta gamma delta will be e by a. So minus plus like this it will go. So here also minus plus minus.
so
So
minus
this,
30 is the product, not 30. 30 is the product.
yeah, that 10 is the product. So the formula will go like this, right? Alpha cube plus beta cube plus gamma cube is equals to 3 alpha beta gamma. So alpha beta gamma will be minus 10. It's not plus 10.
Sure.
So in quadratic also it will pass quadratic also. If your quadratic, this is quadratic, then sum will be alpha plus beta is minus b by a, and alpha beta is c by a, just minus and plus. Here also it is minus plus minus.
Alpha beta gamma is 10 or minus 10?
Product is minus 10, no?
Minus 10 into 3 minus 30.
See, what is our given equation?
X cube plus 5x minus 10.
So what is d here?
Minus 10 is equal to alpha beta gamma.
Not minus 10 is equal to alpha beta gamma. Just compare it with this particular general expression. What is d here?
10 sign has a minus sign.
Okay.
D is equal to minus 10, isn't it?
D is minus 10, agree?
Huh.
When I substitute minus 10 here, what it will be?
Minus 10 will be equal to A into alpha beta gamma.
So this is, see, just tell me the values of A, B, C, D here.
A is 1, no?
A is 1. B?
B is equal to A into alpha plus beta plus gamma.
A into alpha plus beta plus gamma.
Minus.
Okay. Okay. You can see the equation here, right? General equation given to you.
Yes.
B is just the coefficient of x square. Is there any x square term here?
But we don't have the B term.
So B will be 0.
0.
What is C?
C will be equal to
C
A
is the
into alpha beta plus alpha gamma plus beta gamma.
see here.
Yes, yes.
C is just the coefficient of
Given
x.
as 5.
It is given as 5.
Yes.
What is D?
D is minus 10.
Minus 10.
Yes.
So just now I said alpha beta gamma, which is the product, that will be equals to minus D by A.
So minus D by A will become equal to
Minus, what is minus D by A here? So minus
D
D
by
value
A
is
will be
minus
minus
10.
into minus 10 upon 1.
1.
So
What
it will
this
be
will
plus 10.
be? So 10. So alpha beta gamma, which is the product of the roots, will be plus 10.
Okay.
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 So whatever the equation is given to you, compare with this general equation.
Okay.
Sir, I took different approach, but my answer is coming 0. What I did is, by trial and error method, I found one root. That is,
What is that root?
if I put 0, then x minus is one root.
X minus?
X minus 10 is 0. I mean, minus there 10 is one root.
Okay, x is equal to 10 is one root, you are saying.
Put 0 by trial and error method. If I put 0, then x minus 1 is one root. X minus 10
is one root. Then just substitute 10 in your given equation. You should get 0, right?
Okay.
If you substitute, you are going to get 1000 plus 50 minus 10, which is 1040, which is not equals to 0. So which implies x is equals to 10 is not a root.
Okay.
Okay. So this particular thing will not have any integer roots. So difficult to find the roots for this.
Okay, got it, sir.
I have a doubt, sir. Sir, just like activity question, the level of question increase in graded assignment. Sir, does this pattern will also continue to qualifier? Means qualifier question tougher than graded assignment?
No. Qualifier is actually combination of activity, practice and grading.
Okay, sir.
Got it? There will be easy questions, there will be medium level questions, there will be difficult questions also.
And sir, I have one more point. Just you have answered the above question, in which there is minus d by a. I want to say, sir, actually students are confused by this minus sign. They treated minus means negative. And I was also confused in class 9th and 10th. But what I was used to do that I forget that minus represent negative. I would like to say minus does not represent negative. In numbers, in variables, minus means change the sign. Minus is representation of changing the sign. It is a way to change the sign of the number. So minus d by a does not mean it is negative or positive. It only means just change the sign of d by a. Whether it is positive, change to negative. If it's negative, change to positive.
Correct.
So I think, yes, sir. And also this applies to vectors, sir. Minus then change the direction. It does not mean plus x direction plus y direction. Minus means change the direction, change the sign.
Okay. Very good. Very well explained. May I know your name?
Sir, my name is Ritik Roshan.
Ritik Roshan. Okay.
Ritik Roshan.
Ritik, yeah.
Sir, I did not understand, sir. How can we get that alpha cube plus beta cube plus gamma cube is equal to 3 times alpha beta gamma? You said, right, sir?
So this thing, how to get? You want the proof of this?
I did not understand, sir.
I'm just asking, you just want the proof of this one when this is given.
Yes, sir. No, is it direct formula or I did not understand?
It's not that, it's derived formula. You just cube this. Okay.
Okay, sir.
So cube both sides and see the expansion. From there you will get, so few terms will get cancelled out.
Okay.
And alpha beta, how just a second.
Minus 10 is with them.
Okay, you can use this for this thing basically, not this. Don't cube it. You know a cube plus b cube expansion, a plus b into a square minus 2 minus ab plus b square. Do you
Sir,
know this?
actually, this formula was derived, I think, from half of x minus y square, y minus x by expansion. Something like that, sir.
Correct. So yeah. So something like alpha minus beta whole square plus beta minus gamma whole square plus gamma minus alpha whole square. And this will be, so we have to square this and also cube this. We will be getting few terms. So alpha square plus beta square plus gamma square in terms of alpha beta, beta gamma and gamma delta. But see, this is going, we don't need this algebraic expressions at all in our course. You don't need it. Without this only, we just given the explanation, you just substitute that roots in the given polynomial, you should get the value as 0. From that 3 equations, add those 3 equations, you will get it directly.
Yes, sir. Thank you, sir. Yes, sir.
Yeah.
Thank you, sir.
Okay, and yeah, what else? I just said few doubts. If there are few doubts, we will deal it at the end. What are they? I just forget.
नाही ते मला ते minus 10च वाटतंय.
Any doubts?
So that aspirational question.
Yeah, that aspirational question. Okay, let me answer this one-line questions then. So how many questions you can generally expect? 10 to 12 questions, excluding subparts. Okay. So with subparts, it may go to 14, at most 14. So subparts means the same context, it will contain 1 or 2 questions inside it. Okay. And we will give you a blueprint in revision sessions. When the revision sessions happen, we will just give you the weightages also, from which week how much percent will be giving in the quizzes. So that will give you some more insights about the quiz paper. Okay, anyway, those who are done, you can leave the session, and yeah, those who have some small doubts, you can stay back.
Thanks for the
Thanks
session,
for
sir.
joining. Yeah, thanks for joining and have a great day.
Thank you, sir.
Yeah.
Hello, sir.
Yeah.
Sir, about that experiment which I told.
Which you, that multiplicity thing, right?
Yes, sir.
Yeah, just give me 2 to 3 minutes. Let me explain that question 4 to her just by drawing the curve.
Okay.
I will just show her by drawing the curve, and later we can discuss.
Yes,
Okay. In question 4, we have given there are two roads. Road 1, which follows the graph of this curve, this function curve, and there is another road. Rohini Chauval.
I understood that question in which alpha, beta, gamma is equal to minus 3 by 8. Thank you.
Okay. Thanks. Okay. So the g of x is also given to us, x minus 11, x minus 13. So what we said is, wherever this f of x and g of x meets, or wherever this roads meets, at those points there are some aspirational districts. So for that meeting points, let us try to draw the graphs of these two polynomials. Okay, let me draw with f of x with blue and g of x with red. Okay, let us draw red curve first. So this is a quadratic function, right? So this is a quadratic function with leading coefficient negative and with roots 11 and 13. So how will the graph look like roughly? So firstly tell me whether this is an upward parabola or downward parabola.
Downward.
Downward parabola, because our leading coefficient is negative.
Negative.
So downward parabola, and let us say this is 11, this is 13. This is how it will be, g of x, somewhat.
Yes.
Correct?
Yes.
Now let us try to draw the curve of f of x. So now you see f of x has two roots, which are 11 and 13, and 11 has multiplicity
4.
2, and 13 has multiplicity 2. So 2 and 2. Okay.
Yeah.
Both of them having even multiplicities, and the leading coefficient is positive, and the degree. So leading coefficient a is greater than 0. What is the degree? Degree is sum of multiplicities, which is 4, which is even degree with leading coefficient greater than 0. So the end behaviors will be both upwards, both will go to plus infinite. Correct?
Yes.
And multiplicities of 11 and 13 are even, so both at both places it will bounce back.
Bounce.
So it will bounce, it will go somewhere here, it touches or it intersects, it will come back like this. Okay. So this is one point, this is another point, this is another point. Okay, and these are the three aspirational districts. Let us name it D1, D2, D3. Okay, so what we said, oh sorry, this is D3 and D2. So the first two aspirational districts are at x intercepts of f of x and g of x. We said that. So D1 is at 11 comma 0 and D2 is at 13 comma 0. So this we can get from x intercepts of f of x and g of x, correct? You know how to find the x intercepts of f of x and g of x, right?
Yes.
So this we found out. What we have to find is the x coordinate. So this point, we have to find this point. So the x coordinate of this D3 aspirational district. So how do we find that?
Vertex.
So in order to find the intersection points, we will equate it. Okay, it will not be at vertex. You cannot say it will be at vertex. We cannot say, it might touch here also. But one thing we can say, that if two curves are meeting at one point, the intersection point you can find by equating those two curves. So that means at that particular point my y value is same for both the curves. So at this particular point my y value or the value of the function is same. So this f of x and g of x are same at that particular value of x. So same means they are equal. So when they are equal, we can find by equating them. So if you equate, you will be getting like this. So I bring this term to the left hand side because there are some common terms.
Okay.
So if you simplify this and if you find the values of x, you will get the third root. So I take x minus 11 times x minus 13 common. If I take common x minus 11 times x minus 13, and there will be one remained here, this is 0. So if I expand this, so you see x is equals to 11 and x is equals to
11.
13 are
Yeah.
these points, are these intersection points.
Yes,
Okay,
sir.
so we don't want that, so we will exclude that. So we want only this. So x square minus 11x minus 13x plus 143 plus 1 is equals to 0. So this is x square minus 24x plus 144 is equals to 0. So x square minus 2 times 12x, 12 times x plus 12 square.
12 square.
So this is x minus 12 whole square is equals to 0. From here we are going to get x is equals to 12. So for x is equals to 12, my f of 12 and g of 12 are same. So if they are same, they will intersect at one point, at the same point. So this x coordinate will be 12. Okay. Therefore, the x coordinate of the third aspirational district will be 12.
12. Okay.
Okay.
Okay, sir.
Yeah.
Thank
Okay.
you.
Okay. Thank you. And Shivaraj, Jivraj. Sorry.
Yes, sir.
Yeah. So let me share the screen. We will see it in the Desmos itself. Okay. We will try to plot the actual graphs and see.
Yes, sir.
That will be better. Okay. थोड़ा एक दो तीन ग्राफ लेके we will try to analyze if
Yes,
you
sir.
have
Yes.
time. Okay, if you don't have, we can do it in some other sessions. Let me stop the streaming. Okay, you just give me the equation first.
Which equation, sir?
Any polynomial. उसका ग्राफ हम ड्रॉ करेंगे which has multiplicities, more greater multiplicities and lesser multiplicities, and we will try to look at.
Okay,
Okay,
sir. X
something
minus 2
x minus 2.
whole
Will you
power
give
2
any whole power 2
into x minus 3 whole power 5
whole power 5? Okay. Oh, sorry. Okay.
x minus 10 whole power 3.
अरे 5 is we cannot see. कितना जूम किया तो भी it is going far and far. Okay. उसके बाद what did you say? X minus
10 whole power 3.
x minus 10 whole to the power 3. Okay.
Yes, sir.
Okay. So we have multiplicity for 2 is less than 5. 2 is less than 3. So multiplicity of 2 is lesser. And yeah, we are having our turning point closer to 2.
Yes, sir.
Okay, ये हो रहा है. What about नीचे वाला? Oh my god.
This is 2. You should change coefficient.
Yeah, I'm changing the coefficient. 1 by 10,000. Okay. So we can see here. Okay, this is 7.825. Okay. Okay, comparatively, it is closer to 10.
Yes, sir.
Okay, ये तो एक नया observation है. Will it work? Let me try few things.
Yes, sir.
Let us take 5 के जगह 3 ले लें. And it is 1 only. So it's closer to nice 2.394. Okay, so we can say yeah क्या हो रहा है कि if the multiplicities are very nearer, something like 1 and 2 पे बहुत, it won't have much change, you see. I think so.
No, sir, I am talking about consecutive roots. Like both roots are near to each other.
Consecutive roots only. I'm just looking at. Let me put 5. Where? Okay. Okay, तो work हो रहा है, but we should, yeah, we can say like this maybe. We can at least say like this: if it is x minus 2, okay, x minus a times x minus b, sorry, b, and power m, and इसके ऊपर power n है. We'll add all the sliders. So if a and b are consecutive, so maybe let's say 1 and 2,
Yes, sir.
and n is 1 and m is 2. What is this? Okay.
Yes, sir.
So now it should be closer to x minus 1 का closure होना चाहिए.
Yes, sir. It should be.
It should be. Okay. So that means I can say whatever my turning point, whatever my turning point, that is, so if n is less than m, then my turning point, x coordinate of my turning point is less than a plus b
By 2.
by 2.
Yes, sir.
Correct, right?
Yes, sir.
Yeah. Condition is if n is
If
less
both
than
are consecutive and n is less
if
than.
n is less than m and a and b are consecutive.
Yes, sir.
Okay. I should have written it somewhere. So okay, either a and b मान लेते हैं, a and b are consecutive. Okay. If these two conditions must be must. So
Yes,
if they
sir.
are consecutive, and if the multiplicity एक का multiplicity और एक से कम या ज़्यादा है तो then the turning point will be closer to absolute closure to the
Lesser
point which
multiplicity.
has lesser multiplicity. Okay.
Yes, sir.
Okay, I will look. As of now, I am convincing to your point, but even I will check somewhere and I will just refer few research papers about this. and I will come back. Okay. अगर कुछ गलती है तो we will try to rectify it. But good. This is one good observation. Thanks. Even I learned from you.
Okay, thanks, sir.
Okay. Yeah.
Excuse me, sir.
Yeah.
Sir, I have one more doubt
Sir,
in that SSC question.
Mm-hmm.
So can you
can I
open
leave?
that slide?
Yeah. Please. Those who are done, you can leave.
Okay.
Yeah. So what is the doubt?
Can you open that screen, sir? That slide.
Slides. Huh?
Yeah, SSC question.
हाँ, slides में गलत है. Slides are wrong. This one.
No, sir. Sir, actually, we have x and y coordinates. In that, we are calculating y minus f of x the whole square, no? In that, we are getting c square, c plus 3 the whole square, and again c square and c minus 3 the whole square.
No.
So can you open the solved one, sir, which you did?
Okay. Yeah, this one. Yeah.
Okay. Y minus f of x the whole square. So we have to substitute x values in f of x, right?
X values in place of this f of inside this x.
Yeah. So if x is equal to 1 and 3, the term will be c. Answer will be c.
That will be c. But you see, yi is 4, right? So
Okay.
actual minus predicted. So this is actual value. And f of xi is predicted value. So here there will be one more. You can add one more table.
Okay.
Which is f of xi. Okay. F of xi means when xi is 1, you have to compute f of 1. That will be c.
Z. Okay.
And this will be c plus 3.
Yeah. Again
Right?
c.
Again c.
And c minus 3.
C minus 3. Okay. Now,
Okay.
this is actual value.
Okay.
This is predicted value. Okay.
Okay, sir.
So error will be actual minus predicted or predicted minus actual. So in order to exclude the negative, that is why we square it. So even though you take predicted minus actual or actual minus predicted, it doesn't matter because we are going to square it. Anyway, it will become positive. Okay. Now error will be actual minus predicted. For each data point you have to see. So this is actual, this is predicted. So this is 4 minus c is the error. So 4 minus c is the error, and if I square it, it will be 4 minus c whole square.
Okay.
Okay. So like this. So 7 minus c plus 3 whole square. 7 minus c plus 3 whole square for the second point.
Oh, okay, sir. Okay. Yeah. Now I got it, sir. Yeah.
Now, yeah. This is how you should do. Okay.
Okay, sir. Yeah. Okay, sir. Thank you.
Okay. Okay, then. Chalo.
Thank you.
Bye all. Good night.
Yeah, sir. Thank you. Bye.